We're going to start chapter in physics, gravitation. Force. We already have a good idea of a force. Okay. So force is the basic, the energy. Force is force is required to change a speed or direction of any body. Okay. So whenever we talk about motion, forces is going to be there. Right. A motion needs force, right? So motion, to change the speed of the motion or the direction of motion of an object, we need force. So force is very fundamental to motion. So we're going to see how what is the force, present, and what is how it affects motion, and how it is seen in the nature. Let's take an example. Let's take two small, simple examples. An object dropped from a height falls towards the earth. Here you can see, here you can see in the picture, somebody is throwing a ball. When you throw a ball up, naturally, after the motion has expired, after the motion, it goes to the peak and stops there, and it is attracted by by its weight. It's attracted by the gravity, and we know it falls back towards the earth, right? So this is one kind of motion, and we see a force is being acted upon the object, and it is attracted towards the earth. Okay. And again the same thing, we see the planetary motion, right? We see the planetary motion. The sun is there, and our earth is getting attracted, and it moves around the sun. So there is some kind of force between these two objects, right? And we have noticed the attraction between the moon and the earth. Between the moon and the earth, there is also some attraction, right? So the moon is revolving around the earth, and there is some kind of forces already is happening, right? And we know the other example also, the famous thing, the Isaac Newton. He was sitting under a tree, the apple falls, right? So there is a force of attraction for the apple towards the earth. So this Sir Isaac Newton observed these motion, and there is a force controlling or governing this motion, right? And he said that the same force, it is the same kind of force. The nature of the force is the same in all these things, and he called it as the gravitational force, right? So the force between the planetary objects, the force that acts upon an object, okay, and it is attracted towards the earth, right? And this kind of motion is called the gravitational force. Let's see little more in deeper, right? So in this chapter, we'll be seeing this gravitational force, this and the universal law of gravitation. So the gravitational force is a universal thing, right? It behavior is the same across the universe. So we'll see how it affects and what are the laws that governing this gravitation. And we also discuss the motion of objects, right? So we'll also see the motion of object under the influence of gravitational force on the earth. We shall study the how the weight of the body varies from place to place, right? So we may also see that the weight of an object varies, right? An object may weigh more than earth, and it may weigh less in moon. We're going to see how that happens. Coming to the basic concept, what are the physics concept we're going to see is the gravitation, right? So how do we arrive there? So Newton's thinking, Newton is thinking, okay, so what Newton thought is, so there's when an apple falls, it is getting it is getting attracted towards the earth. An object thrown up, right, it's again falls downward, and and so the earth can attract an apple, right? Can it also attract the moon in the same way? Those are celestial objects, right? Earth and moon. So they exist in the huge space. So when an earth can attract an apple, okay, can it does the same thing to the moon, which is also present and closer to earth. And he wants to know whether this force are the same in both the cases. So the force between the apple and earth and the moon, are they both the same? He want to decide upon that. He want to conclude upon that. And he was of the idea that the same type of forces is responsible in both the cases. So he concludes, right? The same type of forces is responsible in both the cases. At each point of its and one more thing he noticed is, at each point on the orbit of moon, orbit is the path, right? So at any point on the orbit, so the moon is going to travel here, okay, the moon is going to travel here in this direction. It is taking a circular path. Moon is getting attracted towards the it's getting attracted towards the earth. Okay, there is some force during this circular motion, it is attracted towards the earth. So unless without that, what will happen? This will this will go in a straight line. So if it is coming here, means it will take the tangent means the point, the straight line. If you saw a straight line and this object, wherever it touch, that is the tangent, and it will travel like this. It will go off, it will go out of control. It will go not out of control, it will go beyond the control of the earth, right? It will go in a straight line. So that is not happening. It is traveling in a circular path, and it is getting attracted towards the earth. So he observed and he said that this kind of motion, force that causes the acceleration, that keeps the motion, and along the circular path, and it is attracted toward the center. This is called the centripetal force, right? So he said that the attraction between objects is the same type of force, and and also the the acceleration is controlled. Okay, it takes a circular motion, and that force is called the centripetal force. Okay, let's take a simple activity. Okay, try an object or a stone in a ring, and you try to swing it around. Okay, so when you try to swing it around, okay, we are holding the other end of the thread, right? So our we are providing a force to hold it, right? And although the object tries to swirl around our hand, it will take a circular path, and it will be it will continue a circular path, and it will be holded in that particular path, because we are providing the force by holding the other end of the thread. So this is an example of the centripetal force. It's otherwise called as center seeking force. It is driven towards the center. The motion of the moon around the earth is due to centripetal force. The same thing we are talking about, right? So we have the earth and we have the moon. We just saw that we have the earth and the moon, and we saw that motion towards the earth is given by the centripetal force. The centripetal force is provided by the force of attraction of the earth. So the earth is attracting the moon, right? And that is given as the centripetal force, which is holding the moon towards the earth and to following a circular orbit. If we take the other example, a falling apple, right? the apple attracts the apple is also attracting the earth. So the earth is the apple falls towards the earth, but we already saw that Newton was thinking, well, is that the other way around is also true, whether the apple is also attracting the earth. Okay, so what can we conclude? What can we conclude is yes, it is also attracted. It also attracts the earth, but we don't see the earth moving towards the apple, because according to the third law of motion, right? The According to the third law of motion, third law of motion, the apple does attract. We've seen, right? Each and each object attracts each other, right? So the apple does attract the earth, and why? What is the and what is the why we cannot see the earth moving towards the apple is it is given the explanation given by the second law of motion. For a given force, right? For a given force, the acceleration is inversely proportional to the mass of an object. So acceleration, the attraction is inversely proportional. So inversely proportional to the mass of an object. So what we are concluding is acceleration is inversely proportional to one of the mass of the object. So if mass increases, okay, acceleration will be very less, very very less, right? It will go down. This will go down if this increases. So mass of the earth of an earth is so huge, right? And mass of an apple is so negligible. So that's the reason we don't see the mass of the earth is so huge. So the acceleration caused by the apple is so negligible that we don't see it at all, right? So that is the explanation given. And that's why the apple goes towards the earth. Apple is getting attracted towards the earth. So with that we can conclude that all objects in the universe attracts each other. So we can conclude that all objects attracts each other, and this force of attraction between objects is called the gravitational force. Okay, so let me rewind what we have seen, right? So force is the fundamental. Force is the fundamental unit of motion, right? We need force to change the speed or direction or of motion of an object. So suppose a body is moving, an object is in motion, then we need a force to change direction or the speed, or to change the speed of the object. Okay, and we have seen the an object falling down. Okay, the planetary motion and planetary attraction is caused by some similar kind of force, right? So Isaac Newton said everything is very similar kind of force. The nature of the force is very same, and he called it as the gravitational force. Okay, and thinking beyond, if Earth can attract an apple, can the attract the moon? Okay, so yes, we've seen that the force between the attraction between two objects, the apple and the Earth, is the same attraction which happens between moon and the Earth, right? So without the attraction, the moon would have gone out of cannot be holded in the same circular path. It would have taken a straight path and moved out, right? So that there is an attraction between Earth and the moon, and we call it as the centripetal force. We call that as a centripetal force because the force of attraction is holding towards the Earth, right? It is acting towards the Earth and keeping it in that particular direction. Okay, so again we going to see why going to see thinking beyond. Okay, so the Earth is pulled towards the Earth, right? A falling apple is pulled towards the Earth. If that the other way around, the Earth is does apple also attracts the Earth? The answer is true. But why we are not seeing that? Why we are not seeing the motion, any motion of the Earth? Why? Because we know by the third law of motion, acceleration is proportional to 1 by acceleration is proportional to mass. So acceleration is proportional to 1 by m. So if the mass increases, the acceleration will be less. So compare this. See the imagine the mass of Earth. It's so huge, right? So it is so huge that the acceleration generated by the apple is very less. That's why we don't see the Earth moving towards the apple, right? And definitely we can extend the same argument between attraction between moon and earth, right? So the moon is so huge, and we don't see the moon getting attracted towards the earth. Sorry, the earth doesn't getting attracted towards the moon. The moon gets attracted towards the earth. So we can conclude all objects in the universe attracts each other. The force of attraction between objects is called the gravitational force.